All right, so for our word problems today, a lot of these are examples that you have seen before, either in another class or you might have seen them in the bingo game on Friday. So I just wanted to go through some examples so you're not totally on your own when you're trying these. But the one thing about these is I can't show you every single example. I'm going to give you a bunch of different examples, but you're going to also have to apply some logic yourself because I can't give you every scenario. So I'm going to give you some hints, we'll go through some, and then you'll have a lot of problems to practice. So we're going to look at word problems that involve right triangles and can be used to solve with Pythagorean theorem, 45, 45, 90 triangles, or 30, 60, 90 triangles. So the first thing we're going to talk about is how you know which method to use. So Pythagorean theorem is the first method, which you're going to use a lot because you use that when you're given two side lengths and there's no mention of angle measurements. So if it doesn't say there's a 45-degree angle or it doesn't say it's a 30-degree angle and all you have is two side lengths, you have to use Pythagorean theorem. And a reminder, that is a squared plus b squared equals c squared. You're going to use 45, 45, 90s whenever a problem indicates a 45-degree angle. For example, if it tells you that two people start walking from the same point, they walk in different directions, but they walk the same distance. That tells you that there's congruent lengths. Or it might even right out tell you that it's an isosceles right triangle. So that indicates a 45, 45, 90. Also, if it just blatantly says 45 degrees, you know that's what you're going to use. Lastly, 30, 60, 90 is when a problem mentions a 30 or mentions a 60. That's when you're going to use the 30, 60, 90 triangle. So let's take a look at a few examples here. The first one says, two trains left the Elizabethtown train station at the same time. So let's say, here's that starting point. It says train A, after 1 hour, had traveled 96 miles east. Let's make that a 96. Train B had traveled 45 miles south. How far apart are they from each other? So we want to know what is this distance. Hopefully you can see the right triangle that's forming there. If it's traveling east and south, those are perpendicular, so it forms a 90-degree angle. And this is an example that's Pythagorean theorem. Because we have two side lengths, we need a third. I don't see a 45, I don't see a 30, 60, so I know it has to be Pythagorean theorem. So looking at this, remember our key is choosing your C wisely. I know my C is the value I'm looking for. So it's going to be 45 squared plus 96 squared equals x squared. And you need to solve from there. So if I take 45 squared plus 96 squared, I get 11,241 for x squared. And I take the square root to get x by itself, and I get 106.02 for x. Notice it says round to the nearest whole mile, so it's going to be 106 miles. The good news here is you don't need to simplify radicals because with word problems we want to know a decimal, or we want to know a number that makes sense to us. All right, the next one says the bottom of a ladder must be placed 3 feet from a wall. The ladder reaches 20 feet up the wall. How long is the ladder? This is like your classic Pythagorean theorem problem. So if we draw a little picture here, I have a wall, and let's just say here's our ground. So the bottom of a ladder must be placed 3 feet from a wall. So if I draw my ladder, looks something like that, and it's placed 3 feet from the wall. The ladder reaches 20 feet up the wall, and we want to know how long is the ladder. So it makes sense. This is the value that's left with no number. Hopefully you can see, here's my right triangle. If it helps you to redraw it, you can do that. So I have a side of 20, a side of 3, and I don't know my hypotenuse. Again, hopefully you can see this is a Pythagorean theorem problem. I don't have a 45, I don't have a 30 or a 60. It's just two side lengths, and I need to find the third. So I can take 3 squared plus 20 squared equals x squared. If we go ahead and simplify, 3 squared plus 20 squared is 409, and that equals x squared. If I take the square root, x is 20.22. The problem tells me to round to the nearest tenth, which is 1 decimal. So it's going to be 20.2 feet. So in each of these problems, you just have to figure out how does a right triangle fit into this scenario. And the more you do them, the easier it will be. All right, next one. An isosceles triangle has congruent sides of 20 centimeters. The base is 10 centimeters. Find the height of the triangle to the nearest tenth. So I'm going to go ahead and draw my isosceles triangle here with sides of 20 and a base of 10. And it is asking me for the height of that triangle. Now hopefully you can see if I have an isosceles triangle, my bottom or my base is horizontal, the height is going to be vertical. So this is where our right triangles come in. So if we want to know the height, we don't have to use this whole triangle. We can just use half the triangle, and hopefully you see that that's a right triangle we've created. So I can draw that left half of the triangle, and it looks like this. I know that my side is 20. My height is what we're trying to find, and we have to be really careful. This is the place where people mess up. This is not 10. This whole thing is 10, so just half of it is 5. So I have a right triangle with a leg of 5, a missing leg, and then a side length or a hypotenuse of 20. Again, Pythagorean theorem. I don't know the angles. I don't know a 45, a 30, a 60. I just have two sides, and I need to find the last one. So I'm going to take 5 squared plus x squared equals 20 squared, and simplify. If I take 20 squared minus 5 squared, I get x squared equals 375. And if I take the square root of that, x is about 19.36. And again, it says round to the nearest tenth, so that's 1 decimal. So 19.4 centimeters. So that's the end of our Pythagorean theorem example. So anything where you're given two side lengths, you need to find the third, is Pythagorean theorem. Now we're going to look at some examples of other types of problems. The next one says, Brent borrowed a road sign to hang in his room that had an equilateral triangle on it. The length of one side of the triangle is 34 inches. What is the height of the triangle? Round to the nearest tenth. So this sounds a lot like our last problem, but we can actually make it a little bit easier. So if I have an equilateral triangle, looks something like this. All of the sides are 34. Now, we could do this the same way we did the last one, but we can actually do it a little bit easier. If I look at this problem, and this is an equilateral triangle, hopefully you remember that every angle in this triangle is going to be 60. And we know now that there's 90-degree angles there when I draw that height straight down the middle. So again, I have an equilateral triangle. They want to know the height of the triangle, so I drew this vertical line down. And I know an equilateral triangle has angles of 60. So hopefully you're seeing, instead of having just any right triangle here, we actually have a 30, 60, 90. So there's my 90. The 60 is that bottom angle there. This one actually always just gets cut right in half, and that's 30. And we have the hypotenuse being 34. Again, you might be thinking, I can just use Pythagorean theorem, which is totally true, you can, but we don't have to. Because if I have the hypotenuse, I can go ahead and write in my formulas for those of you that might want to see that. That's my short side divided by, times 2. So it's 2 times my short side is 34. If 2 times my short side is 34, then my short side is 17. My long side is 17 root 3. So my answer is 17 root 3. And again, we want a decimal because we want it to make sense for our problem. It's 29.4 inches. If you use Pythagorean theorem, you should get that same answer, but it's just a lot easier without it. We knew this was a 30, 60, 90 because it was equilateral, 60-degree angles. So you can deduce that you can use that 30, 60, 90 to solve that. All right, next one. It says, Mr. Reefy hits a golf ball at an angle of 30 degrees. Once you see this 30, you should be thinking 30, 60, 90. How high is the golf ball after it has traveled 50 yards? So we just need to figure out where is this 30, 60, 90 triangle fitting into this problem. So let's go ahead and draw Mr. Reefy golfing. He hits a golf ball at an angle of 30 degrees. So picture that golf ball going 30 degrees in the air. It says, how high is the golf ball after it has traveled 50 yards? So if we're looking for a height, that's always vertical. We want to know how high is it. And here's the bottom, the ground, is that bottom part of the triangle. It says the golf ball has traveled 50 yards. 50 yards, the golf ball is on this path. So that's where that 50 yards is going to go. So we have the hypotenuse of the triangle. We need to know what is this distance here. Now to help you figure out what's the long side, what's the short side, go ahead and write in the remaining angles. I have the hypotenuse, so I know the hypotenuse is 2 times the short side. So if I divide that by 2, my short side is 25 yards. I know that this is the short side because it's across from the 30. If they ask me for the horizontal distance covered maybe, that would be the long leg across from the 60. So that would be a different answer. But all I need is this 25 yards. And the very last one says, a landing plane is approaching the runway at a 45-degree angle. If the airplane is 500 feet above the ground, how far does it need to travel before reaching the runway? Again, here's my 45. That should be like a light bulb going off in your head when you see that. So I have an airplane, which I'm not good at drawing, something like that, okay? And it says it's approaching the runway at a 45-degree angle. So an airplane is going to be going down, approaching this runway, okay? It's going down at a 45-degree angle, and I know it's 500 feet above the ground. So here is my right triangle that I'm going to be looking at. It's approaching the runway at 45, so I know it's a 45, 45, 90, and it's 500 feet above the ground. So it says, how far does it need to travel before reaching the runway? Again, the plane is on this path. So we want to know how far is that plane traveling, not the horizontal distance. We want to know how far the plane needs to travel because there is a difference. So if my leg, remember both my legs are the same, so I know these are both 500, and I need to figure out the hypotenuse. So if my legs are 500, my hypotenuse is 500 root 2 because of my 45, 45, 90 rules. So if I take 500 root 2 and put it in my calculator, I get 707.1 feet. And that's it. So those ones where you can use special right triangles, if you can figure it out, it actually saves you a lot of work. So all you have left to do now is the practice that's attached. So there are 14 problems. You need to decide whether you're using Pythagorean theorem, 45, 45, 90s, or 30, 60, 90s. Once you do that, you can check your answers on the class website. And if you haven't already, you can do that quizzes review to prepare for your special right triangles quiz tomorrow.